Hello and welcome back. Let's take a look at an example of a motor nameplate and all the information we can get from it. We'll also take a look at calculating the service factor for adjusting the overload setting, and we'll be looking at the input power calculation. So let's get started. So here's an example of a motor nameplate. This particular example comes from Electric Motor Control, 10th edition by Stephen L. Herman. It's a Cengage publication. It is from page 75. Now, if you're one of my students, this would be your motor control book. And it's figure 5-9 for your reference. So a motor nameplate can give us a whole lot of information. Some of them give us more information than others. And sometimes you can get enough information that you don't have to look at the spec sheet from the manufacturer, but if you're missing something, you may have to go there. This type of problem, I'm looking for 11 different things, and this would be worth 10 or 11 points on an assignment or test. So the first thing we're looking for is the horsepower rating. Now, if you're in North America, such as I am, then this will be stamped on the motor in horsepowers. Now, if you happen to be in Europe or pretty much a majority of the rest of the world, then it may be a rating in watts or kilowatts. And thus, if you want to convert that to horsepowers, you have to take your kilowatts and use your magic number as 746 in order to change that back to horsepowers. So, looking at this particular example, if we want the horsepower, it's right here, and it says HP, and so we have 10 horsepowers. Nothing to calculate there, just grab the number. Now, the horsepower rating is the output power of the motor. That's what you're going to have at the shaft of the motor. As you may know from your motor theory, what a motor does is it takes electrical energy in and converts that to mechanical energy out. So we have 10 horsepowers of energy coming out. But what about the input power? Well, our input power, as you can see here, is in VAs, volt amps. Now, if it was a simple single-phase motor, we could just take our total voltage by our total current and multiply through and get our VAs. But if you've learned a little bit about three-phase, you realize it's a little more involved than that, because I have 3 hots coming in, 3 sine waves, 120 degrees of separation. And if all the voltages are the same, well, then what we have to do is jerry-rig the formula just a little bit. And so what you do is you take root 3 of your line voltage and your line current. And when you do that, it comes out to 10,596.7 volt amps. 10.6 kVAs if you wish. So here, this is actually a dual voltage motor. That question is going to come up in a minute or two. So we can hook this motor up either to 230 or 460. And again, if it's 230, it's going to draw 26.6 amps. And if we hook it up to 460 volts, it's going to draw 13.3 amps. Twice the voltage, half the current. And it doesn't matter which of these you use. Root 3 times 230 times 26.6, well, that'll get to your 10.596. Or 460, root 3 times 13.3 will get you your 10.596 as well. So either one will work as long as you're using the corresponding current for the corresponding voltage. The third thing I'm looking for here is my service factor, the SF. Now be careful, there may be other things on here. You want to look for the service factor. Now, I do not see anything on here for SF, a service factor. A service factor is basically how hard can I overwork my motor without damaging it? How much can I overstress it? How much extra current can I draw? Let's say the motor gets jammed or a heavy load gets put onto it for a short period of time. What have the designers over-engineered the motor to take? On this example, we don't have a service factor listed. So what do we do? Well, you have to go to the Canadian Electrical Code because that's where we are. Somewhere's around 28306 says, look, if you don't have a service factor, you're going to have to assume it's the lower value. You got to assume it's less than 115% or less than 1.15, which means we'll assume that it's 1.14 for laughs and giggles. That's because there's two multipliers when it comes to your service factor according to the Canadian Electrical Code. Everything that's 1.15 and above, and everything that is less than 1.15. So we'll assume that this motor will err on the side of safety. We'll assume it's less than 1.15. On the motor, next we're going to be looking for what is the speed this is going to spin at under load. And you can see it right here. The RPMs is 1750. 5. Is it a dual voltage motor? Well, we already looked at that. Yes, it certainly is. And it's going to have either 230 or 460 volts. You can hook it up to either one. It doesn't tell us whether this is a 6 or 9 or 12 lead motor, or maybe even only well, it can't be a 3 lead motor. That's for sure, because it's a dual voltage. What are the full load amps or the full load current for those voltages? Well, at 230 volts, this motor will draw 26.6 amps as we stated earlier. And if we hook it up to 460 volts, well, then it'll draw 13.3 amps. Next, if we wanted to select an overload for this motor, how would we go about doing that? Well, the overload is really about how much can we overwork the motor. It protects the motor from being, well, overloaded. And so that is a factor of your service factor. So again, we'd have to go back to the Canadian Electrical Code around 28306. And it says that if you have a service factor less than 1.15, then you have to multiply by 115%. And this is the confusing part of that code rule. Anything that is 1.15, a service factor of 1.15, you have to multiply by 125. Anything that is less than 1.15, well, you multiply by 1.15. And so when you do out that calculation, your 230 volt current is 26.6 amps. Multiply that by 1.15. That gives you an overload setting of 30.59 amps at 230 volts. And at 460 volts, multiplying through means that your overload setting would have to be 15.3-ish amps if you hook it up to 460 volts. From our previous lesson, we learned about our synchronous speed, or the speed of the rotating magnetic field. In order to do that, you'd need to know what is the input frequency, and then you would have to multiply through with the number of poles and all of that jazz. Well, we don't have the number of poles listed on this nameplate. The safest bet, and if you're under a critical care system, you would double check, and you would get the spec sheet from the manufacturer and see what the number of poles are for this particular model of motor. But a general guided rule of thumb is that you can round up your RPMs to the nearest 100 that is a multiple of your frequency, for us 60, or what the motor is rated for, 60 hertz. So you take your 1750, you round that up to the nearest 100, that's 1800, and sure enough, that's a multiple of 60. So it's a safe bet that your synchronous speed is going to be 1800 RPM. The next question is there a connection diagram? Can you tell whether this motor is Y wound or delta wound? No, there is no spec sheet, or sorry, no connection diagram on this particular motor nameplate. So you would have to go to the manufacturer's spec sheet. You have to look that up and see how it's wired, either Y or delta, because that may change how you wire that up as you change from low voltage to high voltage. It definitely will make a difference. So that information isn't available to us on this particular motor nameplate. Percent slip. Well, that works out to be 2.77%. And again, in our last lesson, we learned a whole bunch about how to calculate the percent slip. Basically, it's the difference between your actual speed and your synchronous speed over your synchronous speed as a percentage. And sure enough, when you run this one through, it works out to be 2.77%. So there you go. I hope that helps. That's a really quick abbreviated version of how to get through that. I know some of the other problems are going to be a little more challenging, but I've got faith that you'll be able to figure your way through it. So there you go. And thanks for watching. Oh, don't forget to hit that there like button if this helped. Cheers.